My name is Ben Bowles. I'm Vice President of Products here at NexGen Storage, and happy to be here today and talk about some of the new functionality that we're delivering and what Chris gave an overview of here earlier. The first thing that we're doing around the NexGen QoS manager for VMware, and what that is it's a virtual machine storage management interface. It's a single pane of glass implemented within vCenter. Essentially takes the management of the NexGen N5 storage array and integrates it right into vCenter as a plugin. It's a simple web-based interface, really designed around doing all the day-to-day tasks that administrator, where we see the convergence of roles around a storage administrator and a virtual infrastructure administrator, now being kind of in that same interface, so you can configure, provision, monitor, troubleshoot, all within vCenter with the NexGen QoS manager. A couple things to go through here as far as some of the types of things that the administrator can do through this interface. So we have automated virtual machine storage provisioning, and this goes for whether it's a data store, a VM, or a virtual volume. And so you can do this all through a single interface. It takes the 6 or 7 steps that a administrator that would need to go through, from provisioning the LUN, configuring the access control, setting up all the iSCSI sessions and MPIO policies, automates that down into one step. And so on this screenshot here, you see creating a new data store in policy 1, and it is one-step provisioning and handles all the end-to-end connectivity for best practices, eliminates errors in configuration, that type of thing. And it's all driven from within vCenter. Does it make sense? Any questions on that one?
You call this automation. Do you also have an automation? And this is consolidation, in my opinion. Do you have an automation interface? CLI? Your colleague mentioned the CLI earlier.
Yeah, all of what we show here is also automatable via CLI API.
Is that a REST API? Or?
It's a REST API.
Okay.
And you can use a JSON interface to it as well.
Okay.
Another capability that this exposes by having the storage management integrated right within vCenter is that we can do all of the performance management and quality of service control right in one interface. So this is a screenshot of our metrics tab, and right within vCenter you can drill down into an individual VMDK and see the performance that's on the SAN. And you can get all kinds of different stats. So it's that granular view from data store down to VMDK. We have both the real-time stats as well as historics. You can go back to over a year's worth of data and see the metrics for performance on those different objects. It's available as a UI as well as through APIs, and you can export this information. But really what we're trying to do here is to be able to more easily correlate the end-to-end data path. So from VM to ESX through the network and to the storage, and really streamline the identification of performance issues or problems. There's a 60-page document from VMware on troubleshooting storage performance. And so the real goal we have here is to try to streamline that, provide that information at their fingertips, so they can quickly identify, hey, this virtual machine is having an issue. What volume might it be located on, and do I need to make an adjustment to quality of service policies, that type of thing.
You said you keep the data for a year?
Over a year. You can go to, it has granularity that goes from minutes down to hours, days, weeks.
Yeah, with that granularity, I'm assuming that granularity controls when averages occur.
Correct.
Over time. Okay.
Yeah, so it's a less granular as you go back in time.
Yeah, and gets less useful over time then
Right.
because you lose all the peaks and all that stuff. But, knowing trends and general levels is decent then. Okay, thank you.
Question?
This statistical data, is it integrated in the vCenter Performance Manager? Or is it a separate extension?
This data here is located on our storage array.
Okay.
So it's not yet integrated in.
Do you guys have any integration between something like vRealize Operations Manager or
Not yet.
anything like that? Not yet. Okay.
Not yet. Any other questions?
But I can then take those metrics out using your API or some other method and integrate and feed them into another system. Like, say I have a global SolarWinds or VM Turbo or something like that. I can pull that data into those other systems.
Right. If you want to pull these metrics out and consolidate them into something else, another tool, you can do that as well. Okay, and then on the storage policy-based management, or SPBM, I mean, this is something that VMware's been making a pretty big deal about here lately with this software release of ours. This is our integration into SPBM. And so, through vCenter, we map and I'll go through this quite a bit more as we go through some of the virtual volumes demonstration screenshots and things. But this is how we map our QoS policies to VM storage policies. So the capabilities that are requested through that control plane, presented up through vCenter as a VM storage policy, and then those are exposed as capabilities on our storage, and then the capabilities get fulfilled through the VASA provider. So this is our SPBM integration. It's surfaced within vCenter. You can assign it to a virtual machine. I'll show you how you can even assign that down to an individual VMDK. And then it is dynamic in that we can change it on the fly. So if you need to make changes to the quality of service policies, you can do that right within vCenter as well.
Is this all delivered as a separate appliance, or is this running on the array itself, or? All
this is running on the array.
Okay, so the VASA provider's right on the array.
Yep.
And all that stuff. I don't, because some of your competition, most of your competition, requires multiple separate, or at least additional separate virtual appliances running to implement this stuff. So that's actually really cool.
I think I've got a slide coming up that's on our architecture around virtual volumes, so I think you'll get to see that. But we've implemented all this on the storage array, so there's not a separate virtual machine.
Yeah, all that is extra junk I need to worry about and manage and monitor and make sure it's up, because if I lose that VM for some reason, then I don't have storage policies anymore, and then so cool.
Okay, great. Any other questions? All right, so let's talk a little bit about our virtual volumes integration, and there's a number of different capabilities that are enabled by virtual volumes. Some of the more basic ones around protocol endpoints and storage containers that help with provisioning and VM level granularity, and then there's other capabilities around policies and rule sets, performance mins and maxes. So doing some basic quality of service management, and then we see VM prioritization and predefined policies. So there's some different types that are defined. There's a report that came out that kind of categorized the different capabilities of some of the different vendors. And so, what you see here is that, NexGen, with our VM prioritization and predefined policies in that type 3, we implement the VASA provider on the array as firmware, and then we manage it all within vCenter. Okay, any questions about the VM Storage QoS Manager and what we're doing there? Okay, now we'll go on to new VM level QoS capabilities. Again, my name is Ben Bowles, Vice President of Products here at NexGen Storage. Want to talk to you about the VM level QoS capabilities that we're introducing in our version 3.5 release. And to kick this off, we see that the storage quality of service evolution or revolution that's occurring, started with basic capabilities around being able to manage quality of service on a LUN or a volume level. And so that, obviously a good start. All objects that are in that LUN or that volume would have the same quality of service settings. We had an eye towards virtual volumes with VMware from the get-go with our product and the quality of service that we can do. And so with virtual volumes, now you can take that storage QoS and it operates on a VM or even a VMDK level. And so the granularity, is now really where the customer would like to have it, that each virtual machine or VMDK has its own storage quality of service. And that's integrated end to end with our storage quality of service. And then what we're introducing in this release as well is an IO type storage QoS. And so based on the different types of IO, the system will automatically make QoS adjustments based on, is it a read or a write? What's the impact to the system at its current state? Is it an internal versus an external or application IO? And so we have a much more fine-grained QoS, and this is all automated through our policy management. The end user simply puts their volumes or virtual volumes into the different QoS policies, and then the NexGen N5 software manages that all on the fly for them and automates it. So it's very simple and easy for them to deploy and manage.
So does your QoS per VM only work if you're using vVols? If you got a normal LUN and there's 10 VMs in there, can you still do per VM QoS, or is that still only on the LUN?
The QoS is either on the LUN or it's on a virtual volume, which then is associated to a VM. So I think to answer your question, the per VM QoS is dependent on virtual volumes.
Okay. Which means you have to be on vSphere 6 versus in a 5.5, you'd just be using the...
Right, so the clarification about vCenter or vSphere 6 with virtual volume support to get the per VM granularity. That's correct.
Okay.
And you can coexist your LUN-based data stores as well as your virtual volumes, all on the same next-gen storage. Okay, another capability that we have that we're enhancing is around what we call our prioritized active cache. So the prioritized active cache is the mechanism that, based on the quality of service of those volumes, influences how much data is going to be in flash versus disk. And so the idea is that the active data set is maintained in flash for your higher priority volumes or in virtual volumes based on those QoS settings. So a mission critical QoS setting volume will have the most aggressive warming policy for that active cache, versus business critical would have more normal. And then if it's a non-critical, there's no prioritization of data being warmed back into cache. And so what we've done in the version 3.5 release is we've now integrated this capability with VMware virtual volumes. It also, in addition to managing the flash, the PCI flash in the system, we've extended that to the system RAM on each storage processor. There's a read-ahead algorithm now that's integrated with QoS. So read-ahead is more aggressive on mission critical versus non-critical. So this gives the customer the ability to tune up, how aggressive the caching is for their virtual machines based on what QoS policy they put it in.
Read ahead's a lot easier now with vVols but is this actually a cache? So there's a block. This is a copy being held in the flash rather than just the single copy of the block.
Yeah, so
whatever. It's not
right,
it's not a tier. It is truly a cache.
So we utilize our PCI flash in two different modes. One is on ingest, when data is written, it's a mirrored, essentially a write cache.
Okay.
And we mirror that for high availability, and then we destage down to disk. And then so that's one
that's
part of the way we use
right side,
PCI flash. Then on reads, we can have a read cache. So if the data is on disk, we can have it cached back up into flash.
Do all writes go to flash then, or
All writes go through flash,
Including large sequential.
including all randoms or sequentials. It's a journaled write into flash.
My follow-on to Bob's question is then the flash doesn't count towards capacity of the array at all. Only the spinning rust counts for capacity.
Correct. The advertised capacity of the system is the disk capacity.
Cool.
Good questions. And so the prioritized active cache also incorporates the system RAM, so the data could exist in either disk, flash, or RAM to satisfy an I/O.
what sort of redundancy then exists in the traditional disk subsystem? Is it just mirrored copies? Can I set that? Is it
The data protection we use on disk is RAID 6.
RAID 6? Okay.
Yep. And we do, data that comes into flash, we coalesce it, sequentialize it, and then write it down to disk and try to do full stripe writes and be smart about that.
Yeah, if you've got it somewhere else, you might as well
Right.
take your time and do something intelligent with it.
So what determines if a write goes to flash or to RAM when you have with your prioritized active cache?
We actually don't use RAM as a write cache.
Oh.
We only use the PCI flash as write cache, so it's persisted. We don't have an NVRAM or capacitors or battery back cache. So
So RAM is only for read cache.
RAM is only for read cache. Any other questions? Okay, here's a screenshot of the provision, QoS provisioning within our user interface. It's a little bit harder to see, but we have the 3 different service levels, and then there's 5 policies. The policies are what apply the performance metrics for IOPS, throughput, and latency to the objects that are in those policies. So what's exposed here to the end user is minimum targets for IOPS and throughput, and then a maximum target for latency. And then what a customer can do is, on the fly, they can move virtual volumes or LUNs from one policy to the other, and that is an on-the-fly operation. And then the system then adjusts based on that to meet those new QoS metrics or targets. So a demo that we do for customers is that we exercise the prioritized active caching with the quality of service, and with virtual volumes, what we have here is a demo environment running the latest NexGen code as well as ESX6. We have two Windows VMs running IO meter, and then the initial state is that those 2 virtual machines are in non-critical, so they're not getting any prioritization for caching. And then we migrate one of those to policy 1, so it gets the most aggressive active cache. So the metrics here you see, we're getting about 11 milliseconds of latency, so disk-based performance. And then we go into the virtual machine storage policy management. So this is right on the VM within vCenter, and change it to a mission critical policy 1. And then on the SAN metrics, after we make that change, the red line represents the new latency target, and then the over a matter of minutes, as we populate more data back up into flash, that latency comes down within target, and then is sub-millisecond there at towards the end, and then we go from about 1,200 IOPS to close to 20,000 IOPS. So this is an example of how a customer can control and influence the performance of their virtual machines on the fly. From the VM perspective, this is what it looks like. The green and the blue lines are the two different VMs. We make the change to the VM with the blue line, and then that shows the IOPS increase over time. And then this is the real chart here, which is the change in response time. So you go from disk-based performance with non-critical to flash-based performance as we move more data into flash.
When you make that change to the quality of service level, does it do a read on the pull it back up into flash? Or is new data just populated in flash and it just stays there?
No, it's going to start warming data based on, we have a metrics database, so we have the heuristics of the data. So once you go from policy 5 to policy 1, based on what data needs to be in flash, it'll start warming it back up.
So you've got that list of blocks and frequency of access already.
We already have that maintained in memory. When it's in policy 5, we're just choosing not to act on it. We move it to policy 1, we can now prefetch the data.
Okay, but there's some performance impact when you make a policy change then, because there's going to have to be additional reads on disk, right, to grab that data.
Correct. Yeah. I mean, yeah, we have to read the data to get it back up into flash.
What do those graphs look like for the other VM?
The other VM?
Right there. The other VM.
The green is the other VM. So it just stays, it's non-critical, it just stays where it was.
So there wasn't contention previously, or I would expect his performance to suffer.
In this particular experiment, I think we were running these at about, started off about 1,200 IOPS total, so it wasn't really taxing the system from a contention standpoint.
But it was gated by the response of the spinning rust.
Yeah, it's really governed by
Flash unused then in the.
For these two virtual machines, the flash was not being used.
I see.
So they were
flip
deemed
the
as
policy.
non-critical.
So for some of your policies, then they're only implemented by contention, and then the other parts of your policy determine what storage is allowed to be used.
This was an experiment to show the active caching capabilities. A different experiment would be to have multiple different types of virtual machines running in different policies, and then make an adjustment. I think I've got one of those coming up. But
yeah, because we talked a little bit earlier about these being implemented when there's contention rather than.
That's what I was thinking.
The crux
Yeah.
of your question here is,
I didn't understand we were just allowing flash as opposed to not allowing flash.
Yeah, there's more subtle changes here when you go from non-critical to other stuff.
It affects the caching policy specifically is what we're exercising here.
Yeah, and the 2VM test isn't going to give you
not
that sort of contention.
not a contention-based thing. It's all the time sort of thing in that case. If you're non-critical, you don't get.
It's how aggressive are we with populating the cache?
Yeah. Cool. Not that it doesn't make sense. It's just we're trying to suss out the details here.
Yep. Okay, and then we did another validation where we looked at VM density and the value of our quality of service, and this was an interesting result that we were able to produce, where we ran our system with no QoS and measured how many virtual machines we could support, and then we ran it with QoS turned on, and we get 23% more virtual machines, and it really has to do with how we're prioritizing and categorizing those workloads. A sequentialized workload versus a latency sensitive workload, and putting those more sensitive workloads in mission critical, and then having the non-critical categorization allows us to achieve more VMs. So this was an interesting result that we were able to produce here. So any questions on the new quality of service functionality that we're releasing with version 3.5?
So what happens if I have a bunch of mission critical VMs and the array can't meet the QoS target?
So that question comes up a lot from customers: is what happens if I just put everything in mission critical? So within the mission critical policy metrics and targets, we will attempt to meet all of those performance metrics for the VMs. So we don't get the benefit of being able to prioritize across policies and make those decisions. So if they're overrunning the array with just mission critical, that would be we'd have to identify.
And not even in that case, because I could see potentially some customers doing that. But what if I have a case where it's month end, I have 3 big systems that are mission critical, and they're just pounding the heck out of the array, running reports and doing month end type stuff. What happens at the mission critical level if it can't meet that I/O requirements, and what happens to everything else downstream?
So if we're having trouble meeting mission critical requirements, we start taking away performance from non-critical and then business critical.
Okay.
So that is how the prioritization within our QoS works. Now, if they get to the point where they're even within mission critical, where they're overrunning, that would be an opportunity for us to upgrade their flash to give them more performance. And that's an option. We have a performance pack. So with those metrics, they would know, okay, I'm violating my policies for mission critical.